We would be discussing how to solve one numerical, an important numerical on duct sizing. So the question is as follows. What you see over here is we are required to find equivalent diameter for a rectangular duct. The meaning of finding a equivalent diameter for a rectangular duct is instead of rectangular duct, if you want to use a circular duct, what would be its corresponding diameter? That is the meaning of equivalent diameter. The dimensions of the rectangular duct is given. It means that it is 800 mm by 800 mm by 550 mm. So A aspect ratio is A by B. A is 800 mm and B is, so the cross section area is rectangular, 550 mm. Air would be flowing at a velocity of 5 meter cube per second and there is a correction over here. It is not velocity. The flow rate is 5 meter cube per second. Okay. And the density of the air is taken as 1.15 kgs per meter cube. We need to assume that this flow rate would be the same even for the equivalent circular diameter duct. So the flow rate of 5 meter cube per second, you would be assuming to be the same for rectangular duct as well as the equivalent circular duct. Also, the friction factor is given 0.0015, and we need to calculate the friction loss by assuming the length of the duct to be 100 meters. So there are two problems. One is to find the equivalent diameter and second is to find the friction loss. So how to go about it? So for the case where the air flow rate is same, we need to use this expression. Diameter equivalent is 1.265 in the bracket a cube by b cube upon a plus b whole raised to 0.2 or 1 upon 5, where a is given and b is given. From this we had calculated that instead of a rectangular duct, if the circular duct is there, then what would be its corresponding diameter. So what you see over here is that expression, if you solve, we will get the diameter as 0.728 meters. So this is the first answer of the problem. The second part of the question is you have to find the pressure loss. So for finding the pressure loss, we will first find the velocity, because the flow rate is given. Q is the flow rate. It is 5 meter cube per second, and we have already calculated the diameter of the duct, which is 0.728 equivalent diameter. We know that the cross sectional area of a circular duct is pi by 4 d square. So we put d as 0.728 into square of it into pi by 4 is the denominator. We solve this, we get the velocity of the air in the circular duct as 12 meters per second. Once you get the velocity, we should also find what is the mean hydraulic depth dH, which for the circular duct is d equivalent upon 4. I am not going deeper into the theory as to what is mean hydraulic depth. That we will discuss in some other video. So for a circular duct, the mean hydraulic depth, which is dH, or we can also denote it by m, that is d equivalent by 4, and just divide this value by 4, we get dH. Now once you get the diameter, we have to find the frictional loss. So frictional loss is Fl rho v square upon 2d, where this d has to be the mean hydraulic depth. Velocity we had already found as 12 square. Density is given 1.15. Length, we are supposed to find the friction loss for 100 meters. F is given as 0.0015. Solve this, we will get the friction loss. The answer would be newtons per meter square or pascals. If you want the answer in mm of water column, just divide this by acceleration due to gravity, that is 9.81, and you will get the answer in mm of water column, which is 6.97 mm of water column. So this is how we solve a numerical on finding the equivalent diameter for a rectangular duct, and we had discussed a case where the air flow rate is the same.